Hi, this video is on section 9.1 from your textbook. We're going to try something different for this section, see if you can watch a video, go through it with me, and then work on some questions on your own, trying to make class just be a little bit different. So 9.1 is on something called significance tests, and we're just going to look at the basics. We're going to look at what it means to state a null and alternative hypothesis or hypotheses, similar to your what you've done in science class where you state hypotheses for the scientific method. We're going to interpret something called a p-value. We're going to determine whether results of a study are statistically significant and how to make a conclusion. And then we're going to interpret some types of errors that you can have when you draw conclusions and decide if things are statistically significant. So the first thing that we have to do is just kind of explain where we're going. In Chapter 8, we did confidence intervals. Those were one of the two most common types of statistical inference. Again, inference just means drawing conclusions. We used confidence intervals when your goal was to estimate. Remember I said it's when they ask you what is the population mean or what is the population proportion. In this chapter, we're doing our second type of inference called a significance test, and it has a different goal, and it's the goal of to assess the evidence provided by data about some claim concerning a population. And that will become more clear as we do some examples. So again, a significance test is the formal procedure for comparing the observed data with a claim. So we call that claim a hypothesis, whose truth we want to assess. The claim is a statement about a parameter. Again, a parameter is your population proportion or your population mean. And we express the results of a significance test in terms of a probability that measures how well the data and the claims agree. So we're now going away from finding a sort of estimate to do we have evidence. And that's the way it's going to be stated differently on your AP test. So stating a hypothesis, what does that mean? A significance test starts with a careful statement of claims that we want to compare. We have something that's called the null hypothesis, and we shortcut that to H sub 0. And often the null hypothesis is referred to as no difference. It's whatever there is stated about whatever a company states, whatever we think is happening. For example, when you go to court, you are said to be innocent until proven guilty. The alternative hypothesis is what we're trying to find evidence for. So again, going back to court, that would be we're trying to find evidence for you being guilty. So your null would be, we assume you're innocent when you walk in the door, and our job as a lawyer is to find out, are you guilty? So here's kind of ways in which we state hypotheses. Again, the null hypothesis is H sub 0, so we abbreviate that instead of writing the words. The parameter is either going to be a p or a mu, and then it will equal some value. And I will do an example shortly. The alternative would be, again, H with a sub a. Again, the same parameter, so either mu or p, and we think that it's less than the value they gave us. We think that maybe it's greater than. Or we might think that it's both, that we don't know if it's greater than or less than. And to determine which one to do, it's going to be stated directly in the problem. Again, the first two, when you do a less than or a greater than, those are referred to as one-sided hypotheses. And when you do something that's just different, you don't know whether it's larger or smaller, it's considered two-sided. And it should make sense. Less than is one-sided, greater than one-sided. Two-sided is I don't know if it's above or below. So again, things that we just need to go over quick before we do an example. The hypothesis should express the hope or suspicions we have before seeing any data. So these are things that you do before. Just like when you're in your scientific method, you hypothesize what do you think is going to happen. Again, it's cheating to look at the data first and then frame your hypotheses. Hypotheses always refer to the population. So that's why we were saying population parameters before. And then it is never correct to write a hypothesis with our statistics. So no p-hats or x-bars when we're writing our hypotheses. So let's just do a quick example. This example, if you wanted to look in your textbook, you could, but here it is. A survey of simple habits and attitudes, SSHA, is a psychological test that measures students' attitudes towards school and study habits. Scores range from 0 to 200. The mean score of the U.S. college students is about 115. A teacher suspects that older students have better attitudes towards school. She gives the SSHA to a simple random sample of 45 of over 1,000 students at her college who are at least 30 years of age. State the null and the alternative hypotheses and define your parameter. So what do we want to find? So again, what is our null? Our null, again, we abbreviate H sub 0. And because they're talking about a mean attitude, we are going to use the parameter of mu. And our null is exactly what she tells us about the overall college students in the U.S. So our null is we believe that the college students, all college students, have this mean. Our alternative is what she's claiming. And if you read it again, she suspects that older students have a better attitude. So she suspects when she looks at her college that their mean should be greater than 115. So it's the same population parameter, the same value, it's just a different symbol. And that's the difference between a null and alternative. Now the last thing it says is just define what again is mu stating, and that comes directly out of the question. Again, mu is, just like we were stating earlier, the true mean score for the SSHA test for all students at least 30 years of age at her college. So it's the true mean score for the SSHA for students, and again, you just be very specific. It's basically like you're looking at, well, who did she survey? For students who are 30 years or older at her college. That's it. That's stating the null. That's stating the alternative. And again, defining your parameter. The parameter is which piece are we looking at? And we happen to be looking at means in this question. So that's the first step in doing a significance test. The second step is we're going to do some calculations, but not this section. We'll do that in 9.2. And they're going to give you then sort of the probability of your evidence. So a null hypothesis states the claim that we're seeking evidence against. So we're seeking evidence against this. The probability that measures the strength of evidence against the null is called the p-value. So again, it's like saying, this is our null. We're going to find evidence against the null. Therefore, we have this result. Again, the probability computing, assuming the null is true, the statistics would take on a value extreme or more extreme than the one actually observed, is called the p-value. Small p-values are evidence against the null because they say that the observed result is unlikely to occur when the null is true. So again, it's sort of like when you go to court, if the person is innocent, all these facts are unlikely to be observed to be true if they're actually innocent. So you have a very small probability of that actually occurring. So that's why we have evidence against the null. Large p-values fail to give convincing evidence against the null because they say that the observed result is likely to occur by chance. So it's kind of strange, but small p-values are against the null. Large p-values, we fail to have evidence. The final step in performing the significance test is to draw a conclusion about the competing claims you're testing. So we make one of two decisions based on the strength. Again, we either reject the null, that would be saying that we don't believe this statement, or we fail to reject the null. We believe it. It has nothing to do with our alternative. It has to do with either we believe this about her students again, or we don't believe this. Again, fail to reject the null decision does not mean that the alternative is true. For that reason, we should never use the words accept the null or use language implying that you believe the null is true. It's just talking about how much evidence do we have for or against. So again, in conclusion, nutshell, what does this p-value thing mean? P-value, again, means when your p-value is small, you reject the null. There's convincing evidence for the alternative. P-value is large, fail to reject the null. There is not convincing evidence for the alternative. This is a huge piece of it. This is huge. You want to look that over, review that a few times. Again, when they talk about p-values being large and small, there's no rule about how small p should be. So we require, we basically just start to compare. But we compare p-value with a fixed value that we regard. We call that a significance level. And we write the significance level using alpha, that Greek letter. If the p-value is smaller than the alpha, then we say it's small, and we have statistically significance at that level. In that case, again, we reject. So here again it goes. If the p-value is smaller than your alpha, a significance level, you reject the null, convincing evidence for your alternative. If your p-value is greater than that significance level, you fail to reject the null, there's not convincing evidence. In element of time, I don't know that we're going to do an example for this. I had one right here, but we're just going to keep moving on. The last part of 9.1 is what type of errors could you make? So when we draw a conclusion from a significance test, we hope that our conclusion will be correct. Obviously, we can be wrong. It's like sending a guilty person to jail or letting a guilty person be free. So there are those two types of mistakes, and we call them type 1 and type 2. So type 1 is if you reject the null, when the alternative is true, you've committed a type 1 error. That means, again, going over here, if you don't believe this is, you don't have evidence for this, so then we think it's this, but it was actually true, then you've committed a type 1. If you fail to reject, so you kept the null, when really you shouldn't have, then it's type 2 error. So we'll talk about how can we remember those in just in class a little bit. Again, another way to just look at it is in this table that they provide you with in your book. If your null was true, but you rejected it, that's a type 1. If your null was false and the alternative was true, but you failed to reject your alternative or your null, then you get a type 2 error. So you'll want to study those two types of errors. One more time, just sort of summarized, the significance level is a fixed level. It will either be given to you, or we'll talk about how do you decide what it is. That is, alpha is a probability that the test will reject the null when the null is actually true. So that's kind of, again, that's the probability. Consider the consequences of a type 1 error. So we make our significance test so we know when to reject, but that's also the probability of making a type 1 error, rejecting when you shouldn't have. And again, we'll go over some more examples, and I can't give you all the information. It really helps if you read your textbook. So what I tried to do in less than 15 minutes was tell you how to state the null and alternative, talk briefly about what is this p-value, determine whether results are statistically significant, and interpret type 1 and type 2 errors. I know that was pretty fast, but we're just trying something different, seeing if I can get you the information in that in a different way so that you're more engaged, etc. If you have any questions, again, come in and ask. We will go over this as a class, but feel free to go back through the video or reread your text. Thanks.